right, so this is how, guys, we're going to attack writing the names for ionic compounds, all right, when we have Roman numerals that are necessary. So first thing we want to do, take a look at your cation, which is the dude on the left. All right, it's always going to be the beginning one. If you find it, all right, so Ba, barium, I look at my periodic table. I ask myself, does barium have a split? No, it's always +2. When I mean, does it have a split, I mean it's going to look like this. Is it a chance where it could potentially have multiple charges? If it is, we have to indicate the charge of it with a Roman numeral. If you don't see a split in any of these, then that's pretty much what those things are always. They always are, and you don't need to worry about putting a Roman numeral. So do you see for barium, do we see a split? No. Nope. So you're literally going to write barium. And then the anion, that name's not going to change. Cl, even though it's got a subscript of 2, it doesn't matter. It's just going to be chloride. So we have barium chloride. Okay, let's take a look at the next one. NaF, sodium. We should know, guys, that sodium is always a +1, never changes. So it's just going to be sodium. And what is F? Fluoride. So we have fluoride. That's how I remember spelling it. Ag2O. What the hell is Ag? Well, Ag is silver. Close. You were close. Silver is Ag. Gold is Au. Silver is always a +1 charge. So do we need a Roman numeral? No. It's just silver. And oxygen. All right. Oxygen, you got to know that if it's an anion, okay, it gets an IDE ending. So instead of oxygen, it becomes oxide. So we just have silver oxide. Okay, now we look at the next one. We have CuBr. Look at copper. Does copper have a split? You know what that means? Hold up, wait a minute. We have to figure out and determine what the charge is on that. So the way that I've kind of come across this is always look at the anion first, because that charge will never change. Bromide, always a -1. How many bromides do we see right here? 1. So even though it's not written, I'm just going to write it in just for this little instance, okay, so we understand the concept. Bromide has a -1 charge. What is 1 times -1? So we have -1 charge total on this side, which means in order for an ionic compound to work, the charge totals have to balance. If I have -5 on one side, I need +5 on the other. If I have +4 on one side, I need -4 on the other. Well, you have Cu. How many Cus do we have? And we need to have a total charge of +1. So 1 times what would give me a +1? A +1. And therefore it is going to be copper 1, and we have to write it in a Roman numeral. And then just whatever the anion is, bromide. Let's do one that's a little bit different. Huh? Let's take a look at number 20. I like 20. It's a good number. Okay, Mn. Nope, not magnesium. That's Mg. Manganese. Does it have a split? So we got to do our steps. First step is write the charge of the anion above it. Oxide, guys, is always what as its charge? -2. Okay, how many oxygens do we have? So -2 times 3 gives us a total of -6. So for this to work, how much positive charge do I need to have on this side? +6. How many two or manganese do I have? I have 2. What times 2 will give me a +6? A +3. So this would be manganese 1, 2, 3. Put it in Roman numerals, and then slap oxide there. Yes. It can be, yeah. So these are all right. That's a good question because right here shows manganese 2, manganese 4. Could it be? Yes, it could be. I'm just going to say there could be more of these than there are. It could be just someone making up a problem itself and, all right, just having you understand and figure it out. It could be that there are more than, all right, 2 of each of these, but these would be the most common 2 that you would see. Okay, that is a good question. Yes. Charges. Okay. Okay, so yes and no. So you're talking about a reverse cross of the charge. Okay, it works in some instances, but it doesn't always. It works in some instances, but not always. So let's take a look at number 19. Right now, if you said that, how many oxygens do you have? How many manganese do you have? So what would you say this is if you reversed it? Manganese 1. But what is the charge of oxide again? -2. Okay, so we have 1 oxygen with a -2 charge. We have a total of -2 charge on this side. We need a total of +2 on this side. And how many manganese do you have? 1. So this needs to be a +2 charge. So this would be manganese 2 oxide. So a reverse cross doesn't always work. It doesn't always work. If we saw something like this, we looked at it yesterday, but I'll just re-examine. If you saw PbO2, lead is one of the dudes on the periodic table that can have a split, so we got to indicate, all right, its name with a Roman numeral. Go to the anion because the charge of that never changes. That's a -2. 2 times -2 gives us -4 on this side. So we need a total of +4 charge on this side, right? How many leads do you have? Even though we don't have a subscript, you're supposed to understand that even if it's not written, there's only 1. If there's a 2, then it's 2. But okay, so 1 times what will give me a +4? So this would be lead, Roman numeral 4, which is IV. And then the anion is just its name, oxide. So you can't always reverse cross because if you did, you'd have said this would have been lead 2 oxide. All right. But that is not a bad idea, not a bad guess. Okay. So again, you only need to do that method, guys, if it's something with a split. Sodium is always a +1. So this is just sodium oxide. Beryllium, Be, is always a +2. So it's just beryllium sulfide. Magnesium is always a +2. Magnesium sulfide. Okay, and then let's just take a quick gander at writing the formulas. Calcium. Okay, if it's in group 2, they have all +2 charge. If it's in group 1, they have +1 charge. Group 13, okay, for the most part, +3. Group 15 under nitrogen and phosphorus. Okay, they're -3, -2s, -1s. And anions get an IDE ending. Okay, so calcium iodide. Iodide I know is from iodine. That is a -1 charge. Crisscross the charges. So the 1 is going to come down behind the Ca, and the 2 is going to come down after the I, so we're left with Ca I2. Potassium is a +1. Sulfide, -2. You crisscross. The 2 is going to come down after the K. All right. And another way you can think about it is we need to have the same amount of charge on both sides. Right now, this side has a total of how much charge? We need to have what on this side to balance it out. So how many Ks will we need? Well, you would need 2 Ks because 2 times 1 would be a +2. +2, -2, balance. So that is another potential way you could do it. But the crisscross is somewhat super easy and simple. Silver 1, they don't necessarily need to reiterate that, but silver 1 bromide. If the charges are the same number, just write them without any subscripts. Ag, Br. I want to try this one. Okay, I'm going to skip down to iron 2 oxide. Iron 2 is Fe +2. Oxide is always -2. So if you did the crisscross method, you may see it. You may have written it like this: Fe2O2. But remember, you cannot leave it there. One of the rules, all right. One of the rules is that for an ionic compound, okay, we call it a formula unit. It's the lowest whole number ratio of ions in an ionic compound. So if they're both divisible by the same number, all right, you have to divide it. So this would be what? We would say not this. We would just say FeO. Aluminum oxide. Aluminum is always +3. Oxide is always -2. If you crisscross, you would have Al2O3. 2 would come down behind the Al, the 3 would come down after the oxygen. Someone asked me, well, aren't they technically both divisible by 2? Wouldn't it be Al 1.5 and then O2? No. It would just be Al and O 1.5. No, because you can never have a decimal. You can never have a decimal as a subscript or as a coefficient, which we're not there yet. Yes. All right, but that is what we're looking at. So let me look at something that has. We do not have any of our polyatomic ions in this, but we did in the homework. So I'll just show this again for the homework in case you guys missed it. Chromium 6 cyanide, Cr is a +6, right? That's the Roman numerals for 6. Cyanide is a polyatomic ion that has a -1 charge. I put a small little circle around that because if I wind up with a subscript down here, I have to throw this in parentheses. And that's what happened. The 1 came down after the Cr. The 6 would come down after, all right, the Cn, our cyanide. So remember, Cn is grouped together as one whole thing. So you have to throw a parentheses around it to make sure that you know that there's 6 Cns, not just, if I didn't put parentheses, it would be CrCN6. That would be telling me I only have 6 nitrogen, when in actuality, I'm going to have 6 nitrogen and 6 carbon. If there is not more than one polyatomic, they do not get any parentheses. So ammonium is NH4 +1 charge, and nitrate is an NO3 with a -1 charge. If I were to crisscross, it doesn't matter, they're the same number, so I would reduce. So you're left like that. Do we have any of the other ones in here? No. All right, if we had lead 4 and nitrates, nitrate is the -1, so I would put a -1 behind the PB, and then the 4 would come down after the NO3. But we have to make sure that we have the NO3 in parentheses. Another example would have been zinc sulfite. Sulfite is an SO3 -2. If I just did the crisscross method, it would have a 2 coming down after the ZN and a 2 coming down after the SO3. Yes. If you left it like that, that tells me I have 2 zinc, 1 S, and 32 oxygen, which is insane. So you've got to remember that for polyatomic ion, right, it may be beneficial to just put a small little circle around that and realize if I wind up with more than one of those, I'm going to need parentheses. So you would say, okay, I do have these, so I'm going to need parentheses. But is this the final answer? No, because both subscripts, all right, are divisible by the same number, so they can both be divided by 2. So this has to become Zn and SO3. All right, so you guys have to finish the rest of this for homework. All right, there's no polyatomic, so you shouldn't have any kind of problems with that one. And then this one, we've done quite a few of the examples, so you guys should be good as well. All right.